Residential row house service sizing. In this presentation, we're going to be looking at the rules within the CEC that dictate how we come about determining the size of the service conductors and feeders for a row house residential complex. The rules that we need to know are 8200 subrule 1, 2, and 3, 8202 3A, 2D, and 8106, which has to do with the heat and the AC. Now, within this presentation, I'm going to show row house complexes with identical units. And although it's possible for row house structures to have different sized units, the application of the rules for electrical sizing presents additional complexity that's not really required for the average electrician in this calculation. An additional important difference to a row house complex is that we can have shared electrical loads. And these loads can be in the form of things like exterior lighting, irrigation for a shared area, or a common use building. These shared loads would be supplied from a common panel in an electrical room. So some row housing that you work on will not have these. They'll be very separate. There's no shared electrical, no common electrical room, nothing like that. And so because of that, we wouldn't have to worry about the shared loads. Now, as in all CEC calculations, kVA and kilowatts are treated in the same manner and can be directly added when required without any use of trigonometry or power factor. Well, let's get going and see how we're going to calculate this. Now, this is going to be an overview of the row house calculation process, showing you individual examples targeted on how the rule is to be used. After, we will look at a full row house calculation. So first one, calculate the consumer service for a single row house unit. So we have individual consumer services that come from the main consumer service here. And these are going to be sized to carry simply the load of that individual unit. This over here, well, that would be the main service for the entire complex. So in order to calculate this bold consumer service conductor for a single unit, we're going to 8200 subrule 1. Wait a sec, that's a single dwelling calculation. Right you are, my friend. 8200 subrule 1 is calculating the total demand of one row house unit. Then we determine the minimum consumer service ampacity by comparing 1A and B, and the larger of the two values is considered the minimum single unit service demand required. So 1A, total calculated watts, 1B, default watts, which is often what I refer to it as. The larger of the two is the minimum service demand required. Now, a row house installation is always going to be single phase 120, 240, and so we take that minimum service demand and we divide it by 240 volts. And we take those numbers to table 2 or 4, depending if it's copper or aluminum, for our conductor size, and the ampacity of the conductor we then take to table 13 to determine the overcurrent necessary to protect the wires. Now, the second calculation we have is the main service for the entire row house complex. Now, the main service is here. That's the conductors that have been installed down the service raceway to the main multi-gain meter base. And this is extremely important because it takes into account all 4 units. Now, the rules we use for this are a little more varied. So 8202 subrule 3 AI to VI. Take the minimum single unit service demand and subtract or remove all the heat and AC. Then what we do is we apply a sliding scale calculation to this new lower single unit demand, and that'll give us our total unit watts. Now I'll go through this calculation on the next page of the document. 8202 subrule 3B, well, what are we going to do with all that heat? We're going to add it all together and determine what the total is. We might have to apply section 62. 8202 3C, calculate the total of all the AC. Remember, 8106 subrule 4 will be applied. And so that means that we look at the total heat, total AC, and we decide which one's bigger, and then we apply 62118 subrule 3 if heat is larger. That would give us our total climate watts. Finally, 82023D, common use. Let's say these are common use loads. The electric vehicle chargers are taken as per table 38 values. And table 38 will give us some percentages if we have a whole bunch of electric vehicle chargers. But I'm going to say for a row house unit, pretty unlikely. A2023E is common use loads other than EV chargers, and they're taken at 75% of their rating. At this point, you take all of these subcategories, you add them all together, and this gives us our minimum service demand. We divide it by 240 to get our minimum service ampacity, and then we take it to table 2 or 4 for our conductor and table 13 for our overcurrent. Now let's take a look at that dwelling load calculation I referred to earlier that had to do with removing the heat from the load. So total multiple unit demand, 82023A, item I to V. So let's say we have a row house complex with 4 units. The individual calculated service demand for a single unit in this complex is 34,000 watts after applying 8200 sub row 1. Included in this total is 5,000 watts of heat. So each one of the row house complex units has 5,000 watts of heat. We subtract the heat from the single unit demand right here. That leaves us with 29,000 watts. And then what we do is we apply that 29,000 watts to 82023A item III, because we only have 4 units. The first one's taken at 100%, the next 2 at 65%, and the fourth one at 40%, giving us a total of 78.3 kilowatts. Let's look at a full example. I'm going to provide all of the information for this example, and then we will calculate it out together. So take down the information, pause the video, work it out, and then we can take a look together what the answers are as we go through the process. Okay, so let's take a look at the minimum service conductor and panel size just for a single unit. This one's the calculation that is very similar, or identical, I should say, to an individual residential single dwelling, a detached home. We go to 8201A, the basic load we know is going to be the total living area divided by 90, and then we round up. So we get 7,000 watts. Heat, 6,000 watts. The range, 6.4 kilowatts. Additional loads are taken at 25%, giving us a total of 21.95 kilowatts. Let's continue on. Is that the minimum required for a single dwelling? And the answer is no, it isn't, because we have to compare the calculated service demand against 1B. The minimum given, or the default sometimes, is 24,000 watts. And so the larger value is required to size that consumer service, which means divided by 240, it requires a 100 amp minimum service. Table 2, number 3 OG, 100 amps, and we take the 100 amps to the table 13 to get a 100 amp over current. Now let's calculate the minimum service conductor and overcurrent size for the row house complex, and that's the entire building. 82023A says, subtract the climate from the minimum demand of a single unit. So we have 24,000, look at that. We used the minimum service demand required. Remember, we calculated a much lower value, 21,950. But when we went to this stage, we were forced to use 24,000. Now, when we size the main service, we have to use the larger value of 24,000. Otherwise, our service is going to be undersized. So 24 minus 6 gives me 18 kilowatts, and we apply 82023A. First one at 100%, next two at 65, last one at 40%, giving us a total of 48.6 kilowatts. I then add the sum of the heat of all of the units. There are 4 units at 6 kilowatts each for 24,000, and I apply 62,118. 10 kilowatts plus 14 times 0.75 rather, gives me 20.5 kilowatts. I go to table 38, they say 100%, so 4 times 6 kilowatts gives me 24 kilowatts. And then finally, miscellaneous loads, lights, irrigation, 7 kilowatts. Total, it says take those at 75%. And the total we get is 98.35 kilowatts. Now, just like a single family dwelling, this is considered a non-continuous load. And because of that, we don't have to increase it by 0.8 or anything like that, or even really concern ourselves with what the rating, continuous rating is of our overcurrent protection. It could be 80% rated or 100% rated. It makes no difference because this demand is allocated or determined to be a non-continuous load. So table 2, sizing it to 409 amps, gives me a 600 kc mil. And I take the 420 amps from the wire and I size my overcurrent from table 13. Let's do one more example with a Rowhouse service. This one's a 6-unit Rowhouse complex, and we've got special permission granted by the inspection authority as per 6104 to do this. I'll let you take down the relevant information, calculate out the main service conductor and the service conductor or consumer service for each unit, and then unpause the video. Okay, so now let's calculate the minimum service conductor and panel for a single unit. 8201A, we have a basic load of 8,000 watts. The heat is 0 watts. The AC is 8 kVA. The range is going to be 6,000 plus 2 times 0.4, giving me 6.8 kilowatts. Additional loads are taken at here 6.2, and we've got times 25%. So 6.2 plus 4 times 25%, 2.55 kilowatts, a total calculated service demand of 25.35 kilowatts. We compare that against 8200, and this is larger, 25,350. Larger size equals size of the service. We take this divided by 240, we get 105.6 amps minimum service. Now, I have no idea why there is a 23 million number there. It's a typo. Overcurrent device for the panel board is going to be 125 amps, and the service conductor size for this particular unit will be a number 2 og. Now remember, these two values, number 2 og service conductor was taken from table 2, 75-degree column, and the overcurrent 125 amp was taken from table 13 based on the service or the ampacity of this wire. Now let's calculate the minimum service conductor and overcurrent for the entire Rowhouse complex. 82023A. This time we subtract the climate from the minimum service demand, which is 25,035 kilowatts, or 25.35 kilowatts, minus 8 gives me 17.35 kilowatts. We take this value and we follow it down cascading through 82023A, and we get 58.11 kilowatts. Now we have the sum of all the AC, which is 6 times 8 kVA, giving me 48 kVA. And then we have 82023D. We actually had 8 electric vehicle chargers in this one. So table 38 said, based on their rating of 6 kilowatts, we need to take them at 90%, giving us 43.2 kilowatts. 82023E, miscellaneous common loads, lights, irrigation, 12 kilowatts at 75% gives me 9 kilowatts. Finally, we add all of those together and we end up with just over 158 kilowatts for the total townhouse service demand. And if we take this and divide it by 240, we end up with 659.6 amps minimum service conductors. Now, for this particular example, I'm just choosing to go parallel. There could have been a few different other options. I suppose we could have done single conductors or something like that. But honestly, most of the time, we're going to be looking at attempting to reduce the size of the conductors. I mean, these are freaking gargantuous. I would be installing 2000 kc mil for 659 amps. And for this example, I thought, you know what? That's pretty excessive. Now, this answer here, that obviously is not correct. We would be sizing our service conductors based on 329.8 amps.